Okay, so this video is going to be a full diagnostic and eventual repair of a 2008 GMC Sierra um, 1500 pickup truck with the built-in trailer brake control system. So that's the factory installed GM option of a trailer brake controller. And this particular truck had the service trailer brake system error whenever you'd start it up, as well as the tbcm code C1112 on the Tech 2 when you ran the codes on it. So yeah, this follow along on this video and we'll see how it all worked out. So the next step in our diagnostic journey will be to check various voltages, and we'll be starting under the hood at the fuse block. So first we check the voltage that comes from this breaker right here, and that powers this stud here. You see we got 12 volts. The next thing is the ITBC, which is 6. And you check this fuse, is 15 amp fuse. We got 12 volts on one side of it and 12 volts on the other side of it. So that fuse is powered and good. The other thing involved in this circuit is, in this case, fuse number 43, which is labeled miscellaneous ignition. That's right here, which is here, which translates to this one here. You have to check this one with the power key on. So check one side. It's got good volts. Check the other side, and it's also powered, so that one's good. Okay, so from all the stuff that we did under the hood, what we've verified is that we have power on the circuits that are supposed to have power, and those are the circuits that feed the trailer brake control module and the trailer brake solid state relay as well. So we know that there's power there, but what we get back here, and what I've done is I've put a prop on the brake pedal and turned the key on, and you'll see that what we're getting for voltage on the pin back here, which is for the electric brakes, which will be this one here. What we are getting for volts is only 1.4 volts. Now, why that's a problem is because the trailer brake control module is expecting to see around 3.4 to 4 volts on that circuit, and if it doesn't see that, then it sets that message off up front, and essentially the system doesn't work. That's its sense. It's looking for that voltage at the computer in order to verify that the system is working. So this is basically the fault that we have that's causing that message, is that we have only 1.4 volts, and so now what we're going to have to do is go through the diagnostic process. Yeah. Now the simplest solution, and the one that most other YouTube channels have proposed, is to change the solid state relay. I bought one of those on Amazon for about 35 bucks, and I've already tried changing it, and it did not fix the problem. It's an easy swap, just unplug it, plug the new one in, and I got the exact same results. So we have to deep dive a little deeper into this to figure out what's actually going on. So here is the relay that I purchased off of Amazon. See the part number there. This, as I said, didn't fix the problem. So in this case, the easy solution is not the solution that's going to work. Now I've dug up all these system schematics online and poured through them and checked voltages all over the system, but I'm going to show you the next part of this, which is to go through this diagnostic process here to figure out what's actually going on. Yeah, this is for a C. One of the things that this test is going to verify is the problem based on a code C1112 fault, which comes up on the GMT1 scanner that I hooked up to this thing, and that's what it told me I had, was a C112 fault, which is the low voltage on that circuit. So yeah, that's what we're going to do now. So what you're going to need to go through this diagnostic is a couple of things. One, you need a voltmeter. Next, you're going to need these instructions, and you're going to need a couple of wires. This is 032 lock wire, just a little piece, and that will fit into that plug. So the first thing you need to do, first of all, this is your integrated trailer brake control module. This is the computer. On this truck, the relay, the digital relay, is right up here. From what I've read in the manuals, it's not always there. Sometimes apparently it's on this frame rail, but in this case it's here, and it's as easy as unplugging it like that, because I've had it off several times, but when I first took it off it was not that easy. So the first step in this manual is ignition off, disconnect the harness connector at the solid state relay. Number 2, test for less than 5 ohms of resistance between the ground circuit terminal B and ground. Okay, so we're going to test for resistance. In this case, this meter, I have to change the plug. Okay. Ground circuit terminal B, which you can see here, is the second one. So B is going to be the black wire next to the dark blue wire. So you go up here, and you can see the blue wires here. So the next one, this is going to be B. We get our wire, and we'll plug that in here. Okay, so we've got our jumper wire in terminal B. That corresponds to the black wire, which is ground, and we're going to test resistance now. And where I've got the other end of my ground hooked up is right up here at the trailer plug, on the ground lug on the trailer plug. So that's what we're going to use as our ground reference. And check this side. And what do we have? We have essentially 0.5 ohms of resistance. So we've got 0.5 of an ohm of resistance, so that's good. That's within scale. That's within the range of what's acceptable. Because what they say you're looking for is test for less than 5 ohms of resistance between the ground circuit terminal B and ground. So we've passed that. So the next thing is, again with the ignition off, verify that a test lamp illuminates between B plus circuit terminal F and ground. So what this is going to do is verify that there's power coming from that lug up at the fuse block that we just tested. And that feeds this wire right here. And so what we're going to do, first of all, we need to change this over to volts. Okay. And we check for power here. What do we got? And we've got 11.77 volts, so that is good. So we've got power coming back here, no problem. So, next part of the test. Okay, the next part of the test is turn the ignition on. Ignition on, verify that the test lamp does not illuminate between control circuit terminal E and ground. Okay, so that's going to say that we want control circuit terminal E is the yellow and black wire. Yellow and black. Okay. That's the one next to where we're at currently. Okay, so the voltage check which we are currently going to do is for pin E. That's the yellow and black wire, as you can see here. And what they want us to check is the voltage between that and, let's see here. Right, so ignition on, verify that a test lamp does not illuminate between control circuit E and ground. So we don't have a test lamp, but we have a voltmeter. So what we can do is check the voltage here. See what the voltage is. And what we get is 9.15 volts. 9.15 volts is pretty high. That would probably turn on the light. So that's a problem, according to this test. Okay, so what they're looking for is checking the voltage between control circuit terminal E, which is the yellow and black wire, and the B positive, which is the red wire. So they want us to check the voltage between those two. So that's what we're going to do. Put another pin in here, and then we'll take the black wire and we'll juggle this around. Shaky cam tells us what. So the next test, we verified that the voltage between terminal E and B plus is 1.8 volts. Next test is ignition on. Test for 3.2 to 4.1 volts between the control circuit terminal C and ground. So, control circuit terminal C. Terminal C is the tan wire. So, take this back up to ground. Move this to the tan wire, which is the third one from this side. And we check voltage here. And what do we get? We get nothing. 0.1 volts. So voltage between the tan wire and ground is coming in at nothing, and it's supposed to be 3.2 to 4 volts, 4.1 volts. Control circuit C and ground. So that's our first problem right there. Control circuit C is the integrated trailer brake relay control active low. So what does that tell us? Well, it tells us if less than the specified range, test the control circuit for short to ground or an open high resistance. If the circuit tests normal, replace the tbcm. Well, we're going to carry on to the next step. We'll do that wire test at the end. So the next test is ignition on, test for 3.2 to 4.1 volts between control circuit terminal A and ground. So terminals A is the dark blue, and that is heavy gauge dark blue wire. This is what it ultimately ties into the trailer brake plug at the back to power the brakes. And so what do we get here? We've got 3.568 volts, 3.569 volts, which is exactly what we're supposed to have. So this tests out good. Oddly enough, when you plug that in and test the voltage at the back of the plug, it drops to 1.4 volts. So that's where we've got a fault. Right now, this has got the voltage it's supposed to have on it, but we've verified that the tan wire does not. So that's I believe the tan wire is the controlled wire for the relay. So the next one is, so we've done 7, which is control circuits A and ground, dark blue. So the next one is ignition on, test for less than 1 volt between the control circuit terminal D and ground. So D, let's see here, D is a light green wire. Right, light green. So, pin out of there, pin into here, and that works out to A, B, C, D. So we check this, and D is giving us 0.14 volts. It's supposed to be 1 volt, it is not. So there's the second part of the fault. Basically, the two control wires for that relay. So that, what is a D? No, D says relay feedback. And C was the integrated trailer brake relay control active low. So those are the two faults. We got problems on those two wires. I suspect that means that we need a new trailer brake control module. Now, the next thing we can do, just to verify that there's no problems in the wires, is we can turn the ignition off. We can disconnect here, and then we can test the resistance between those two wires and ground to make sure that there's no shorts in the circuit. Yeah, so we can do that next. That's the next step, and once we've done that and verified that, the next step has to be this. Okay, so now the ignition key is turned off, and we are going to disconnect this plug here. It's just like that. And we disconnect that. And now we're going to check not voltage but resistance. So we swap this over. There we go. Need to get a tripod or something. Okay. So we're now going to test what we've got for resistance between this circuit and the tan wire and ground. And what we have is no continuity, which is exactly what we want. Oops, you can see that's still hooked up. So that tells us that this circuit is not shorted. Next, we go to here, which is the tan wire. That was the other one that we had a problem with. And we check this. And again, no continuity, which tells us that there's no shorts there. These wires are not shorted, therefore the most likely problem, as far as the diagnostic tells us, is that this module is faulty. So that's it. Next step is to order this module, and I have already checked the price on it, and it can be had for approximately $86. So one thing I didn't mention is that this module, unfortunately, is not just plug and play. It is going to have to be programmed to this truck. I'm pretty sure it won't work if that's not done. So when I get it, I am going to have to go through the adventure of figuring out how to update modules through my Tech 2, and I will show that as well. I've never done that before, but I believe it can be done with the Tech 2 and with just a $40 one-time use fee paid, which is probably a lot cheaper than what the dealer would charge. So I'm going to go through that and show you how to do that too.